Hello everyone, welcome to AWS Tutorials. In AWS Tutorials, you learn about AWS Services. And today I'm going to talk about data ingestion services in AWS. I am bringing this topic over here because when I work with my customers, many times I'm come across scenario where my customer is confused about which service to use for data ingestion, because there are AWS services which have duplicate capabilities, and it look like in a particular scenario that more than one service fit the goal, can do data ingestion. Then which one to choose becomes a big confusion point. And that's why here I'm going to cover this topic over here, where I discuss some of the scenarios I have frequently come across, and I discuss what are different factors, design elements you should keep in mind when selecting the right service for your data ingestion in a particular case. So let's get started. Just to set the ground, this is how the typical ETL pipeline look like, and I have shown this diagram 100 times. You must have noticed it if you are following my video. So basically, in a ETL pipeline, you ingest data from some data source, and then you move data into three different stages: raw, cleansed, and curated. And you also catalog your data in all three stages so that your data is discoverable, your data is searchable. Now today I'm going to talk about data ingestion only. So I'm going to talk about some external data source. From there you bring your data to your data platform, and I will take examples of various data sources and various AWS services which can be used for ingesting the data, and how should you be deciding which AWS service to use for data ingestion. So data ingestion is the focus of the discussion today. Now, where is the confusion, or what is the confusion? The thing is that there are many data sources. There are databases, there are APIs, file system, ERP systems, IoT devices, streaming data, or social media data. There are various places or various sources from where you might want to ingest your data. And in order to ingest your data, you have got multiple AWS services which can do the job. There are list of services which can be used to ingest data from each of these data sources I have mentioned over here. But there are scenarios, and sometimes it's very clear cut and simple decision that, I'm dealing with this kind of data source, I choose this AWS service to ingest the data. It's a very clear decision, and I will talk about those examples as well. But sometimes you really have a confusion that I'm talking to one data source, but then I have more than one choices within AWS to ingest the data. Now, how do I choose which one to use? And that is what I am going to discuss here in the rest of the presentation. And first of all, let's take an example of a confusion state. So for instance, suppose you're trying to ingest data from a database. If you're trying to ingest data from a database, there are multiple choices available. You can write code into AWS Lambda function, which can talk to database to ingest the data. You can write code into AWS Glue job, which can talk to database to ingest the data. Or you can also use AWS database migration service to ingest the data. Now, three choices available. Which one I choose? That confusion I will try to solve in the discussion today. Another example, if you're trying to ingest data from any of the ERP system, like SAP, for example, in that case, do you want to write a Lambda function which can talk to ERP SDK or API to ingest the data? Or do you want to write an AWS Glue job which can talk to either SDK or API, or it can talk to database of the ERP system to ingest the data? Or do you want to use AWS AppFlow kind of service which is designed to ingest or transfer data from SaaS application, ERP applications to AWS services? Now, which one I choose? So again, this is what I'm going to discuss today. the data source, I'll talk about each of these data sources, what different choices you have, and what factors to consider when deciding about a particular choice. Now, I know that I am touching a little sensitive topic over here because I can be killed anytime people saying that why you talked this particular choice and there are 100 other choices available. So yes, I know how diverse this topic is, how and what kind of potential this topic holds. So let me set some ground rules here, or some ground to cover the scope for me here. I have not talked about any AWS partner solutions here. So there are many AWS partner solutions which you can use to ingest data from various data sources. I'm not covering that in my discussion today. Now, technically, a lot of things can be done. Our service can be used in 100 ways. Many of the AWS services has got duplicate capability. And in that case, actually, there are so many choices which are available, and it is not possible for me to cover all the choices. So I am going to discuss some of the choices here which I frequently come across in discussion with my customer. And if you think that some of the choices I have not discussed here, please let me know in the comment section. I'm happy to discuss it with you, and I'm happy to make a video about it if it feels like that topic is very interesting and should be shared with the audience over here. Finally, there's always room for innovation. I'm going to give you some approach to do the integration, do data ingestion, but you can always come across a different approach for it. In that case, if you think that some of the innovation you have thought about, some of the way you have thought of is not discussed over here, some improvement can be made, please do discuss about that in the comment section. Again, I'm happy to have one-on-one chat with you and also make a video about it if we feel like it's such an interesting topic to discuss with the wider audience. Okay, so with these ground rules, let's get started. So first data source I want to talk about is a database. So there are many times you are trying to move data, ingest data from your databases to your data platform. And in that case, you will have roughly 3 choices. Either using a Lambda function to do that. So in case of Lambda function, you will like a Lambda function code using your JDBC libraries, like the example I gave here for the Python, like scikop2 or MySQL Python. So these libraries you can use with your Lambda function. And in this case, generally you keep your connection information into Amazon's secrets manager. So like your host name, your port, your login name, password, those information you keep into your secrets manager securely. And then you run this Lambda function based on schedule or event to ingest data into your data platform or say S3 bucket. Okay, so that's Lambda function approach. Glue job looks similar, but a little difference here. So in case of, you can also do data ingestion using the glue job. In that case, you try to use glue connection. Now, either you can use out-of-box connector, like Glue has out-of-box connector for MySQL, PostgreSQL, Oracle, SQL Server, or you can also create your own custom connector. So custom connector route is also possible with a Glue connection. So basically, your Glue job uses Glue connection to connect to your database, and then it ingests your data. Again, Glue job can be run based on schedule, based on event, both. And the third approach which you can take is using database migration service in AWS, where you configure a DMS replication server, configuring both source and destination, and then you can create a replication task in that replication server to do migration from your database to your data platform in AWS. And again, this replication task you can run based on schedule or based on event. So roughly these 3 choices you will come across when you're trying to ingest data from your database. So how do I make decision? So the 4 factors I'm going to consider here for making the decision are: Is your work configuration driven or code driven? That means, are you going to write code to get the job done, or are you going to do configuration to to complete the job? Okay, and why I'm choosing this option over here, because many customers have developer community and they are okay to write the code, but many customers don't have developer community and they like to use some configuration driven approach. Data size is second factor. Data size matters a lot when you're trying to make choices between these three options over here. Whether you want to do incremental data or not, that is so full data, of course, everyone can do, but do you want to move incremental data? And if you want to move incremental data, how these three different choices work, it's very important for that option to understand. Then when you're trying to ingest your data, do you want to perform any transformation? Generally in ingestion, you don't perform transformation, but sometimes you have to do some very basic transformation. Generally, you try to keep your ingestion data or your raw data, because generally you do ingestion to your raw data stage. And in that case, you want to keep your data immutable, so that it can be traced back to the source. And for that purpose, you don't perform transformation, but sometimes you have to perform transformation. And in that case, that transformation becomes one factor which you need to consider when you are making the choices between these three services. And finally, at what frequency you want to ingest the data. You want to ingest data per day, per minute, per 5 seconds, per 15 seconds. That also actually is one of the consideration you should keep in mind when deciding about one of the three services. Now, there could be factors beyond these 5 points, and if you think about that, please, again, I'm open to discuss that in the comment section of this video. So let's see how these three services fare against these 4 factors. So talking about a Lambda is not a configuration driven. You have to write the code. That's the bottom line. You have to write your code. Since Lambda has limited resources, again, not limited resources in terms of memory, because now with the latest announcement, Lambda memory can be configured very big, but Lambda still have a timeout period of, if I'm not wrong, 15 minutes. And in that case, you don't want to deal with very large amount of data in Lambda, where the whole ingestion can take more than 15 minutes, because in that case, your Lambda function will fail, will time out, and you will not able to ingest. So keep that in mind, that your Lambda function is good, but only when your data size is small, because the whole execution time cannot go more than 15 minutes, and your memories has also have limit. It does not have unlimited memory or very large memory, which is possible with other choices. You can do incremental data, but for that you have to believe in some custom logic. So for instance, if your data has got some kind of timestamp value, then when the Lambda function run, you make note of that Lambda function. When the next time Lambda function run, you compare the previous run with the timestamp changes, and then based on that you identify the incremental records, and then you move them. So you have to build a custom logic when you're using the Lambda function. Transformation, you can do limited. Again, it's not a technical limitation, because you can use AWS Data Wrangler and those kind of libraries to really do very complex transformation. But again, when you're trying to use the transformation can result into a long execution time, as well as big memory consumption, which could be a limiting thing for Lambda function. And that's why transformation can give you some limitations when trying to use inside AWS Lambda. But Lambda function is very good if you have very high frequency ingestion, like if you want to run Lambda function every second, every 2 seconds, every 5 second kind of thing, Lambda function can really do it for you. So these are the assessments you have to keep in mind when you are trying to choose Lambda function as a way to ingest data from your databases. In case of Glue, is it a configuration driven or code driven? It is mixed because AWS Glue does provide Glue Studio, which takes away lots of complexity from the coding point of view. You can configure your pipeline. So, but many times you have to write your code as well. So I will say AWS Glue is a mixed one because you do have a choice to do configuration driven pipeline as well, but many times you have to write your code to do the ingestion. You can handle all kind of sizes here. So glue can go really very big. So basically, I won't say it's like unlimited size, but yeah, definitely you can handle very large data sets with AWS Glue. Glue again can do incremental thing. Either you can use job bookmark kind of concept to do the incremental thing, or you can also use custom business logic similar to what Lambda does to handle the incremental values, incremental data in Glue job. It can perform all types of transformation. Since Glue does not have any short execution limit, and memory of the Glue can go really very big, memory and CPU both. You can assign to a Glue job can really go very big, and that's why it can handle a very complex transformation, you can handle complex transformation or long transformation. So it can really handle all types of transformation when trying to ingest your data. However, the frequency of Glue job cannot be very high. So generally, if you look at today's Glue job version 2.0, the startup time is around 1 minute, and then it takes some time to finish the Glue job, depending on how complex the Glue job is or what kind of transformation or data it's dealing with. But keep in mind your startup time is roughly around 1 minute at this point of time. So suppose you want to ingest data every 15 or 20 seconds or 30 seconds, Glue job is not going to fit your need. So your frequency is little high when it comes to Glue job. Similarly, when you're trying to use database migration service is completely configuration driven. You don't write any single line of code over there. You simply configure your replication server and replication task, and replication task takes care of configuration driven data transfer or data ingestion. It can also handle large data size, since generally data migration service is not a service, is used for migrating the data, as name suggests, but it can also be used for ingesting the data because it can handle Redshift S3 as a target destination, and that makes it a very suitable service when it comes to data ingestion. So it can really handle very large amount of data. You have to increase the size of the replication server as depending on your data size, but yeah, you can really handle a large amount of data. DMS can also handle incremental data because it supports change data capture, CDC. Since it supports CDC, you can really do incremental data ingestion using DMS. DMS cannot do any transformation. So maximum you can do is you can select certain fields, but nothing beyond it. Like you can apply a select filter, not select filter, the select columns in your database and filters, but nothing more than that. You cannot do any real transformation in DMS. So you can say transformation is almost no when it comes to DMS. Again, the frequency of this cannot be very high because generally it's like when you're using DMS, you're using DMS for large amount of data migration or ingestion, and in that case the frequency is not is not high. So if you ask me about my personal choice, which service to choose, and if ask me okay, given three things, which one I will like to give, which one looks like more balanced choice to me, in my opinion the most balanced choice is Glue. Because it can handle all types of transformation, it can handle all types of data sizes, it can look into incremental data, it can be built without writing a single line of code or even writing the code. And with 1 minute runtime startup time, I think it's not a very bad frequency. So it's not as good as Lambda, but yeah, I mean, it gives you a kind of a good middle ground. So Glue is generally my choice when it comes to data ingestion. And again, I'm saying it's my choice, need not to be your choice when it comes to database-based ingestion. So let's take another example. For instance, API. When you're talking about API, you roughly have two choices, whether you can use an AWS Lambda function or you can use AWS Glue job. And in case of AWS Lambda function, you can use API library. Like if you are using Python, they can use requests kind of module to write a code to talk to API and fetch the data. You can keep your connection information, like whole API connection information, API authentication information into Amazon Secrets Manager to manage your credentials over there. And this Lambda function, again, you can run based on the schedule or based on the event. In case of Glue job, again, it looks very much similar to Lambda function, where you can actually write Glue job with APIs and with API library like request module I talk about in case of Python. Here also you keep your connection information in Amazon Secrets Manager and you run based on schedule or based on event. So these approach are like both code-based approach using almost similar code. Only thing is that one code you're writing into Lambda function and one code you're writing into Amazon AWS Glue job. So let's try to compare these two choices over here. So talking about the Lambda function, it is completely configuration driven. It's completely code driven. It is you cannot handle very large amount of data size here in Lambda function, and to be honest, API does not provide you large data size. API generally provide you small data. APIs are not designed for giving you terabytes of data. So if you're talking to API, basically you're dealing with small data. That's more or less given. If someone is creating API for data ingestion with large data, I mean, he should think about it. Yeah, let's take that way. Again, you can handle incremental data as well, but in that case, mostly you'll find that business logic is with the API. So API, depending on when it is called, should be designed to give you incremental data. You can build a custom business logic within AWS Lambda function, but generally since API is not giving you the whole dump of data so that you can compare the timestamp, it's giving you just, generally API should give you incremental data only. I mean, let's take it that way, okay? Because API is not supposed to give you the whole data. It just need to give you data which should be given at the time of the call. And generally that data should be your incremental data, right? You can perform transformation. Yeah, actually perform. Generally, since API is giving you a small amount of data, your transformation requirements are not very complex. So you can do all types of transformation. You are not limited by execution time over here because, again, the baseline is that API does not give you large amount of data. So generally, you will not hit execution, Lambda function execution limit or execution duration limit or memory limit. Again, you can go for very high frequency, which is generally happens that you go for very high frequency to make call to the API to ingest data. In case of Glue, it looks similar to API, similar to Lambda function, but only one thing is different, which is your frequency. Again, since Glue has 1 minute startup time, at this point of time, it cannot be run in a scenario where you want to run a Glue job every 15 seconds kind of thing. Again, the Glue job, you have to write code because there is no connector or there is no configuration driven approach when you're trying to bring data from API. So you have to write code similar to Lambda function, but here you can handle all types of data sizes, all types of transformation. And to be honest, size doesn't matter here much because, as I told you, APIs are generally not designed to ingest large amount of data. And also it can handle It can handle incremental as long as API is handling the incremental data. Because again, API does not give you all the data. I mean, like, you can build a custom logic if API gives you all the data, but generally you don't design API like that. So API should be designed in such a way that it gives you incremental data whenever it is called upon at a particular point of time. So when it comes to API, generally I find that Lambda function is more suitable here, and reason being is that Lambda function actually, mainly, I told you the API are not designed to give you large amount of data, and in that case you don't want to go for glue job, because Lambda could be more cost effective. It can run more frequently to fetch the incremental data from the API. So both performance wise, cost wise, and the feature wise, you can see the 5-factor wise, Lambda is more suitable when you're trying to bring data from APIs. Moving on, what about ERPs? And ERPs, when I talk about ERPs, I'm talking about solutions like, for instance, softwares like SAP or Salesforce and those kind of softwares, or ServiceNow, or if you want to bring data from those systems, what are different choices available? And one choice is, of course, using Lambda function. But in that case, your Lambda function will either talk to ERP SDK or API if it is available for the Lambda runtime you want to build in. And then you keep your connection information into secrets manager. You make call to the API to fetch the data. Yeah, I mean, this is a choice available, but it is not so popular. But Lambda function can be run then based on schedule or based on event. Then comes your glue, and glue actually can work in two ways. Glue can talk to API similar to Lambda function, or glue can also talk to ERP database, because generally ERPs are running in front of the database, and sometimes you can have access to database, and in that case you can talk to database directly. So either you can use API approach to talk to the ERP API to fetch the data, or you talk to ERP database using glue connection, either out of box or custom connector, to fetch the data. And in both of these approach, actually you can run the data ingestion based on schedule and also based on events. And the third choice is app flow, where you can configure a flow between your ERP system and S3. And this flow actually will simply take data from your ERP system and dump into S3, for example, as a location here. And then, and again, this flow you can run based on schedule and also based on event. However, here, one thing you need to keep in mind that these are the current softwares which are supported by AppFlow. So you can use AppFlow as an approach only when you have the list of softwares you see here, that software you're dealing with, that ERP system you're dealing with. If you're dealing or those kind of applications you're dealing with, okay? If your application is not listed here, then AppFlow is not a right choice for you. So let's try to compare these three approach again. So talking about the Lambda function, again, it is completely code driven, good for small data sizes. Again, because of the execution duration limit as well as memory limit. It can do incremental data, but again, generally I will expect that API handles the incremental data, because if ERP API is giving you all the data in one go, sometimes ERP's APIs do pagination. They give you 100 records, then 100 records, then 100 records. But the problem is that Lambda then in that case can use a custom business logic to do the incremental data, but then this whole execution duration of the Lambda function becomes a bottleneck there. So again, if I'm using Lambda function with ERP APIs, then I will like my ERP APIs to handle the incremental data and try to give only that data which should be given at a point of execution. Transformation again is limited here, and limited not because you cannot write a code for transformation, limited because you are limited by the memory of the Lambda function and also execution duration. And frequency can go again very high when you are using a Lambda as a way to ingest the data. Now moving on, when you talk about the glue, glue can do mixed, and it can do mixed because if you're talking to database, you can go completely configuration driven. If you're talking to API, then you have to go completely code driven. So yeah, you do have a choice to build the whole job of data ingestion through configuration or code or mix of both. You can handle really big sizes of the data in AWS Glue, so it can handle all the sizes, small, medium, big. It can do incremental thing, and there it can use custom logic. Well, in case of API, it should be using API should ideally handle it, but it can also use a custom logic approach because again in glue job I can go for very big memory, big CPU, and my timeout period is very large. So I do have a kind of an option in my hand that even if API dumps me the data or do pagination of data for me, I can build my custom business logic to select the incremental data. Because I don't have any sword hanging on my neck for the timeout period of 15 minutes. So literally I can build my custom logic when you're using the glue. And of course I can use job bookmark, especially if I'm trying to deal with the database. I can do all type of transformation in glue job, and again the frequency is not very high for the obvious reason I have talked about earlier. In case of app flow, it is completely configuration driven. You don't write a single line of code. Actually, it's a completely configuration driven approach to transfer data from your ERPs or applications to the AWS platform. You can really handle a very large amount of data. It supports incremental transfer, and incremental transfer configuration changes from application to application. Like you're using ServiceNow or Salesforce or SAP, your incremental transfer configuration might be different, and in some case it might not be supported as well, just to be very clear over here. So you might have to see based on application by application, but yes, it does support incremental transfer. So yeah, it can do incremental data ingestion as well. Transformation is very limited, and you cannot really go much complex there. It provides some way to concatenate your data, whether you can probably delete part of it, or you can cut the data, you can mask the data, you can concatenate the data. I think things like that you can do, but nothing beyond it. So it does provide transformation, but very limited transformation. And again, the frequency is generally not very high in case of app flow, because this is designed for a large amount of data ingestion, and in that case the frequency is not very high. So when you're trying to select between these three choices, actually my first option will be app flow. And why I'm going for app flow? Because when I'm trying to ingest my data, and I'm ingesting my data into raw bucket, and in that case transformation is not such a requirement for me, because I really, to be honest, there should not be any transformation when trying to bring data to raw bucket or a raw area in your data platform, because you try to keep your raw data similar to your data source so that it can be traced back to the source, and it is kept immutable. So transformation, which is a limitation of app flow, is not a big thing for data ingestion in my opinion, but other things are fantastic here. It is totally configuration driven. It can handle incremental data. It can handle all types of data sizes. So app flow really suits when it comes to talking to applications or ERP system. But Airflow has a limitation, and that is there's number of application it supports at this point of time. Though that list is increasing, like if try to compare how the list was looking like, supportability list was looking like 3 months back to now, the list is growing. So it will grow for sure in the future. But if at this point of time you are trying to use Airflow, that it in certain scenario, it might be case that your application is not supported at AppFlow at this point of time. And that's why here in this case, I'm talking about a second choice, and that second choice is AWS Glue. And Lambda is definitely not suitable because in Glue, you do have a choice to talk to API and database both. And many ERP systems support OData interfaces. In that case, you can write code with OData interface to ingest the data, or you can also, and generally this OData interface supports pagination, so even they can handle large amount of data. And in many cases, these ERP systems or application have also provided access to the database. So Glue can actually talk to both API and database. So Glue is a good fallback option if your app flow is if your application is not supported in AWS App-Flow at this point of time. So moving on from ERP, let's talk about the file systems. Now, in case of file system, there are roughly three choices available: transfer family, data sync, and storage gateway. In case of transfer family, actually you can configure some kind of SFTP server which has a sync to the S3 bucket, and then your data source can use some kind of command line script to upload data to the FTP server, and then FTP server will simply dump that into S3 bucket. Generally, this kind of ingestion happens based on the schedule. Data sync works similar thing, but in this case they use data sync agent, where data sync agent can take data from your file systems and write to the S3 bucket, and such transfer of data also happens based on the schedule. And you can also use storage gateway, though primary purpose of the storage gateway, just to make no confusion here and be very straight, that primary function of the storage gateway is to do the data backup. Okay, not data ingestion. But sometimes I have seen people using AWS file gateway as a way to transfer data from on-premises to the S3 or from file system to the S3, and such transfer can also work based on the schedule. So roughly you have got three choices available. Now, if I try to compare these three choices, basically what you'll find is that all three have got similar profile here. So all three are configuration driven. Basically configuration and code driven both. In fact, storage gateway is completely configuration driven. That's a little exception there, but otherwise rest are your configuration and code driven. So basically the whole, like in transfer family and data sync, you can configure like you can configure SFTP server, or you can configure data sync agent. But when you're trying to upload data, or when you're trying to run this data sync, or you want to schedule it, you have to sometimes write some kind of script to do that, and that's why it is mixed over here. In storage gateway, it's completely configuration driven. You don't need to think much. You don't need to really run a script to schedule something to run. Your data size all can handle small to big, all type of data sizes. They all support incremental data, incremental files based on the timestamp. They support no transformation, because they are for file level dump. They are for file level copy, file level sync. They don't do any transformation whatsoever. And the frequency again are like mid to high, okay, in all three cases. So in this case, all three have the same profile. Only storage gateway is a little different because it is completely configuration driven. But if you ask me my choice, which one I choose, I will choose either transfer family or data sync, because AWS storage gateway is designed more for data backup. It's not designed for data ingestion. So in my opinion, you should be going for either data sync or transfer family. So data sync, if you can deploy a data sync agent in your file system environment, and then you can configure data sync agent to simply move your data from your file system to the S3 bucket, or transfer family if you are okay to provision an SFTP server in AWS with sync to S3, and then you write some kind of script at the file system level to keep dumping incremental data, timestamp based data to timestamp based file to this FTP server to ingest data into S3 bucket. So in this case, in case of file system, transfer family or data sync are more suitable compared to storage gateway. Now, in some cases, there are not confusion. So those are 3-4 scenarios I talked about where you have a confusion, you have multiple choices. But in some cases, you don't have a confusion. For instance, when you're trying to ingest data from social media, since social media is a streaming data, is a high volume, high throughput data. You use Kinesis to bring data in. You can sync this data to S3 bucket. You can use Firehose to transform or not transform the data. You have both choices. And Kinesis Firehose also supports data cataloging for streaming data, so you can leverage that feature as well. So like in case of social media, I mean, I will not ask you to think about any other choice. Simply go for Kinesis, because if you're dealing with high volume, high throughput data, Kinesis is the best and the only service which can do this job in AWS. Now, if you try to understand, again, 4 factors, just for the knowledge sake, not that you're comparing with some other choices over here, for the sake of knowledge, is it configuration driven? No. Mixed. If you're trying to ingest that data as it is without transformation, then you can do completely configuration driven. Only thing that ingestion part, you have to write a small code. But if you're writing a transformation, depending on you're writing a transformation, like in a Lambda function or somewhere else, then in that case, you have to write the code. So it's a mixed approach. It's not completely configuration driven. You have to do configuration and coding both. Data size, you have to look in a different perspective here, because here data size is not very large, but it's very high throughput and high volume of data. So from that point of view, you really handle very large volume of data, but when data comes to you, it is not that big. But it's a continuous streaming of data, which is important here. You don't need to worry about incremental data in this case. That's the good news, because social media feeds and those kinds of timestamp based data. So you simply get incremental data, new, like in a social media, new feeds coming in are ingested. You don't need to worry about the times, like any kind of incremental data, because whatever data you get is a new data, is a new timestamp data for you. Generally, so transformation also you can do limited transformation in this case, because you generally use Lambda function Lambda function for the transformation. And in that case, since Lambda function has got an execution limit as well as memory limit, you can do transformation, but not very large amount of transformation. But generally, this is not a very big thing, because since it's a streaming data, you don't have much data to transform, and you can actually very much handle transformation within 15 minutes, but still think about it. That's why I put limited over there. And frequency is very high in this case, but only thing is that you can do batching. So sometimes you can use Kinesis Firehose to do batching of your data when you're writing data back to your S3 bucket in your data platform. So that's how the social media thing works. And the next one is IoT, which is very much similar to social media, because in this case also what you do, that your device are using X509 certificates for authentication, then they are sending high throughput of data to you, because IoT devices are also the use cases. In their use case, they send you high volume and high throughput of data, and the rest of the thing looks similar. You send such data to Kinesis Firehose. You send such data to IoT core, and then IoT core will simply route this data to Kinesis, and then Kinesis will simply write data to the S3 bucket, and then Kinesis can also do transformation or no transformation using Firehose, and data can be cataloged again in this case. So in case of IoT, you use IoT core for authentication of your devices, and also for MQTT based messaging, so devices can send data to you. But after that, the whole data handling is handled by Kinesis and other Kinesis family of the services. Now, if you try to again compare all those 5 factors here, it's again, is it a configuration driven? No, it's a mix. You config and write code both, especially if you're writing transformations and those kind of things. It can also handle high throughput data. So large data is not a problem here, but depending on how many devices you are handling and at what frequencies devices are sending data to you, you are generally dealing with very large amount of data, very large volume of data, high throughput data. Again, incremental data is not a worry for you because it is a timestamp based data, and again you can do limited transformation because you do transformation using lambda function, and in that case you are limited by your execution time as well as the memory. And again, you can really ingest data at very high frequency, but generally you use Kinesis to do batching of the data before you write to the S3 bucket. So you batch for certain time or certain size before you write data to your S3 bucket. So in case of IoT also, you generally don't have confusion. You know that you're going to use Kinesis and AWS IoT Core to ingest your high volume of data generating from your devices. So in conclusion, when you are selecting your solution for the platform, for the type of data source, try to make selection based on data size, whether incremental data or one-time full data or transformation and frequency. Performance is undergiven over here, security is undergiven over here. Try to make your solution selection based on these parameters. Don't make your selection based on cost only. Sometimes people have a tendency to say, hey, glue is cheaper or more cost effective than, lambda function is more cost effective than glue. So let me use lambda function, not the glue. Yes, lambda function might sound more cost effective than glue, but lambda function can give you limitations at certain point of time when you're trying to handle a complex transformation, large amount of data ingestion and those kind of things. So keep this in mind. Don't make decision based on the cost. Make decision based on the data size, incremental data, type of transformation you want to perform, at what frequency you want to ingest the data. So that was all for today's videos, guys. I don't have any demo. It was more of a talking about various data ingestion technology. Hope you liked the video, and if you like, please click on the like button. Please subscribe to my channel. I always look forward to your feedback in my comment section, whether you want to discuss some of the things I talked about, or you have some problem you want to discuss with me, or you want to give a request for some new content. Please write those things into my comment section, and I am happy to talk about that in my comments, and also make videos about that in the coming tutorials. So I look forward to your feedback, look forward to your comment. I promise to come back again in a week's time with another video. In the meantime, stay safe and have a nice day. Bye bye.